Hey there folks, and welcome back to chemistry. As you may have guessed from the opening there, our question for this week is what happened to the balloon after a day in the freezer? To help answer that question, we're going to do an experiment using this syringe. The syringe mimics the balloon because the air molecules inside are able to expand, meaning they move further apart and take up more space, or contract, meaning they get closer together and take up less space. We call a container that can expand or contract like this a non-rigid container. Now, in our experiment, we're going to try to figure out how changing the temperature of the gas inside the syringe affects its volume. Let's take a look. So in this experiment, again, we're going to try to figure out how the temperature affects the volume of the gas. Usually we measure temperature in Celsius, but this time you'll notice I'm using a new unit here called K, or Kelvin. It's really easy to convert between Celsius and Kelvin. You just take your degrees Celsius, add 273, and you have your Kelvin. So for example, if something was 10 degrees Celsius, I'd just add 273 and get 283 Kelvin. If something was 15 degrees Celsius, again, I'd just add 273. 273 plus 15 is 288 Kelvin. Now there's a really good reason why we're using Kelvin, which I'll explain on the data document. So I'm going to start off just at room temperature. The room I was in was 25 degrees Celsius, so I'm going to add 273 to that and get 298 Kelvin. Now at room temperature, it's kind of hard to see on there, but take my word for it. It was about, you see the little numbers on the side? Those are milliliters. So that plunger comes to about 4.2 milliliters of volume for that air. Now we're going to try ice water. So we're going to let that sit in ice water. And we're back 2 minutes later. And check the temperature there. It's about 2 degrees Celsius. 2 plus 273 gives me 275 Kelvin. I'm going to go ahead and check the volume now. Notice how I push on the plunger there? That's in case the plunger gets stuck to the sides of the container, and it allows us to get a more accurate volume for the gas. This one's tough to see because the plunger's blocking the 4, but it comes like right below the 4, so I'm going to call that 3.9 milliliters for this trial. And now we're going to try some hot water. We'll let it sit in there for a little bit. So I checked the temperature of the water off camera, and it was about 80 degrees Celsius. Add 273 to that, and you get 353 Kelvin. Now this is a noticeable difference in volume. And that plunger comes to about 5.2 milliliters for our hot water trial. Now, between that experiment and the information that I linked in the summary table, you have enough information to answer the question, what happened to the balloon after a day in the freezer? I'll show you what actually happened on Friday in a post on Google Classroom. Let's take a look at some quick announcements which apply to the next 5 weeks. Our question for this unit, this whole unit, is how does a weather balloon work? And I'm going to show you more about the weather balloon in future videos, but just know that each week the activities I'm having you do are like puzzle pieces that can help you figure out this question. Now, being able to piece together scientific information to come up with an explanation about how something works is a skill that you're absolutely going to need to be successful in college and also just in life in general. So it is absolutely worth your time to be engaging with this. Over the next 5 weeks, this is pretty much how it's going to go. You're going to watch the weekly YouTube video, and then you have 2 options for how to engage with me beyond that. Option 1 is you're going to complete the summary table. That's available either on Google Classroom or in the distance learning folder, and you can share it over email or on Google Classroom. Or alternatively, you can attend one of my office hours, which I'm going to hold every weekday at 2 p.m. on Google Classroom. Go to Google Classroom to see the link to those. I hope you all have a great week, and I'll see you soon.